Hello and welcome to this edition of Around the Dial with Dave. Today we're going to talk about the effects of measuring zero on a meter and what that really means. So in front of us we have four different meters. They're all measuring essentially zero. Oops, here I'm going to bring these, my mistake. I'm going to bring this into the AC range and you can see the meter on the left. Oh boy, here we go. The display's reading zero, this meter 0, this meter 0, and this meter 0.6. So we're going to discuss that in just a little bit. But what I wanted to mention was on a previous version of Around the Dial with Dave, we talked about the effects of range, resolution, and accuracy. So today we're going to specifically focus in on resolution. Now, the meter on the left has a resolution of 1 full volt AC. The meter here, 1/1000th of a volt, so you may not be able to see it, but there's a decimal, so 0.000, so 1/1000th of a volt. Same for this particular meter. Now in this meter, we actually can measure 1/10 of a thousandth of a volt, so 1/10,000th of a volt is being measured here. But you notice they're all nicely measuring zero. Well, just as a quick recap, on that other video I mentioned, think about you're driving down a highway and you're doing about 63 miles an hour, and you look at your speedometer, and how fast can you really tell that you're going? If you have the old analog style pointer speedometer, you can tell within a mile or two, plus or minus a mile or two, up or down. So you know you're going about 63, maybe 64, maybe 62. But you can get a general idea of how fast you're going. If you have a digital speedometer, then of course it's going to show you you're going 63 miles an hour. And I also continued on to say, well, if you needed to know 1/10 of a mile per hour, I'm not saying this makes sense, but you needed to know 1/10 of a mile per hour, well, then you could go out and buy a speedometer that would resolve 1/10 of a mile per hour until you're going 63.2 miles per hour. If you had more money and more need, you could go to 1/100th of a mile per hour. You could even go to 1/1000th of a mile per hour if you really needed to. Again, I'm not saying it makes sense, but that's what you can do. Well, imagine that same car with that thousandths of a mile per hour resolution speedometer, and you're stopped at a traffic light. You've got your foot on the brake. You are not traveling, but a gust of wind hits the car. You're going to measure it's going to indicate that you're going some imperceptible speed, but it's going to show maybe several thousandths of a mile per hour. Or if a big truck rumbles by and shakes your car, it's going to pick that up. Well, in a very similar fashion, that's what you're seeing in front of you. So we have 4 meters. They're all essentially reading exactly zero. But here is why. On each of these meters, I have the leads plugged in, you can see, and I have them shorted together. So I'm going to bring up one set of leads. Here, oops, and of course they fell apart just as I came up. When we put them together, it nulls it out or zeroes it out. As soon as I disconnect it, we start picking up, in this case, about 14,000, 16,000ths of a volt AC. And what is that? So now all I'm doing, you can see I'm increasing it. It's up around, around 100 or so. I've got these stretched out to form a V in my arms. So really what a set of test leads are an antenna. So as soon as you expose them to radiated noise, electromagnetic interference, they're going to pick that up. And then all we do is come back, clip these two together. I'll do that out of the way. Of course, my backlight just went off. And now we're back to zero. So the same thing is true. We'll turn these backlights all back on. The same thing is true for this meter. Here we're measuring 10,000ths of a volt. So 6/10,000ths of a volt. I'm going to pick that lead set up, see if I can lift it up without it coming apart. Tough to do, but we'll see what we can do. As soon as I take it apart, it starts picking up radiated noise. And the more I stretch it out, the more of an antenna I have, and the more residual value on the display. I bring those same two leads back together, merely, short them out, and it settles right down. So that's the important thing to realize, that if the meter can resolve finer and finer values, it's going to do it. This particular meter is showing just hundredths of a volt. So even when, and the leads are not together, as you can see, but because it can't see tens, hundreds, or thousands of a volt, it doesn't pick up anything. And when we measure voltage, we get a full volt resolution. We don't see any decimal place or anything to the right of the decimal place. So I hope that helps you understand a little bit about why a meter may actually show something when nothing is plugged in. It's just because of its sensitivity, and it's coming up with some values. That's it for this edition of Around the Dial with Dave. We hope that helped.